All right, to review this, to start with the area model, I am going to show you the one that we started with today during class. We had the 2x squared equals 15x minus 25. I am going to break this down with step-by-step area model just in case we forgot some of the main steps with it. So with this, I am going to keep the a value positive whenever we are setting this equal to 0. And that's simply because when the a value is negative, the signs get all mixed up and it doesn't work out as well. So if we were to keep the a value positive here, and we were to subtract the 15x and add the 25 and get our 2x squared minus 15x plus 25 equals 0. When we are going this route, if you go with your little x method here of a times c and b, a times c is 2 times 25, 50, b is negative 15. As we talked in class, those two values need to be negative 10 and negative 5. Negative 5 times negative 10 gives you that positive 50, and then adding them together gives you that negative 15. So with the area model, where I saw most issues happening was once the box was created, once our area model, and we fill it in, you fill in the a value in that top left corner, 2x squared. Fill in the c value in the bottom right corner, 25. And then the other two are from that b term, are basically us breaking up this b. So if you think about we're going backwards from a multiplication, these two boxes typically combine together to be that b term. So we've broken them up to be negative 5x and negative 10x. From here, it is taking the greatest common factor, and we do that going up. So the greatest common factor of 2x squared and negative 5x is just going to be x. Now, one of the key rules with the area model is you keep the sign of the top and the top row in the left column. So this top row, the 2x squared, is positive, so this x is going to be positive. Over here, negative 10x and 25, the greatest common factor here is 5, but because the negative 10 is negative, we need to bring the negative up with us. And then we do our greatest common factor going out. So 2x squared and negative 10x, take out our greatest common factor here. That would just be 2x, but because the 2x squared is positive, we're going to keep that 2x to be positive. Negative 5x and 25, our greatest common factor here is 5, but because of the 5x being negative, this is also going to be negative. We write these together, so our factored form is 2x minus 5, and x minus 5 equals 0. If we were to multiply this out, we will get back to 2x squared minus 15x plus 25. All right, and then to actually solve, because our whole goal was to originally solve, 2x minus 5 equals 0, x minus 5 equals 0. Add the 5 over, you end up getting x equals 5 halves, and x equals positive 5. Now I do want to do a comparison to why there is the issue. All right, so over here, I'm going to do it with the issue that we ran into during class today, just so you can see the difference and see why it creates a problem. So if we were to take it where our a value was negative, again, I do not want you to do this. I just want you to see it so you can kind of have a better idea of what happened. So when we solved this in class, we had 0 equals negative 2x squared plus 15x minus 25. All right. So when we see this, if we go the exact same method, I'm going to try and follow our steps pretty exact over here. So we have our x value. Now our a times c is actually it's still positive 50, but our b value is now a positive 15. That is going to change these values to be a positive 10 and a positive 5. So then when we fill in our area model here, everything seems to be looking similar. Our a value is negative 2x squared. Our c value is negative 25. And then to plug in the broken up b value, 5x and 10x. Everything looks like it is a-okay. However, when we start to do the greatest common factor going up, you're going to see running into some issues with our sign. So going up negative 2x squared, and actually I'm going to change these just so that they're in the same spot so you can really see 10x, 5x. All right, the greatest common factor of negative 2x squared and 5x is still going to be x. But if we follow the rules of how the area model is supposed to be done, it is taking the sign of the top row. So this x should be negative. 10x negative 25. This GCF is 5, but now that 10x is positive, so the 5 is going to be positive. All right, let's go out. Do the column going out. Negative 2x squared and 10x. Our GCF here is still 2x. However, again, following the standard rules of the area model, this negative 2x is negative. So we're supposed to be putting this negative out here. Again, just following the rules of what you've probably been taught with the area model. And then this 5x minus 25, take out the GCF, it's going to be a positive 5. Now when we write this, right, let's say that we haven't caught the error yet. If we write this out, negative 2x plus 5 times negative x plus 5. If we were to, we'll put it equal to 0. If we were to multiply this out, it does not give us the quadratic that we were actually factoring up above. Because if you do negative 2x times negative x, that is going to give you a positive 2x squared. Whereas when we're trying to factor with this, it's a negative 2x squared. So this is where the area model just gets hazy with factoring with a as a negative value. Is it impossible? No, you can kind of reason your way through it possibly, but I think, in my opinion, it's too big of a gamble to go with. In theory, okay, if we were to, because some of you may see this, if we were to still solve this, all right, negative 2x plus 5 equals 0, and negative x plus 5 equals 0. If we were to take this and follow those rules and solve it, you will see that our solutions end up being the same. So you subtract 5, divide by negative 2. This solution is still 5/2. Over here, this is still x equals 5. However, this is not okay. All right, this is not okay. Why is it not okay? Yes, it is great that we got the same solutions, but when we do something called rational functions, we need for this, your actual factors, to be correct. And if they are not correct, if the factors you get here do not actually tie back to this polynomial, right here to our quadratic, there is going to be an issue with the entire unit of rational functions. It's just not worth the gamble, in my opinion. So this was the issue that we are seeing in class when it came to solving with the area model. Now, in a couple other videos, I am going to do a couple more examples with the area model and then a couple more examples with the grouping. Feel free to go watch those videos. I wanted to start with a video explaining the issue we were having during class.